Hello, this is Pre-Cal Lecture 2.9, where we are going to talk about variation, and you have some pre-printed notes for this one, so let's get to it. All right, variation is the notion that two quantities can increase or decrease in relation or proportion to each other, and direct proportion. Two quantities are considered directly proportional if when one changes by a certain percentage, the other changes by the same percentage. So you've got some space in here to draw this arc example that I'm going to give you. All right, so let's say we've got an arc. All right, and it goes about halfway in the first quadrant there. And then let's say we've got another arc that's further on out, but also goes about halfway. So what if the two arcs are directly proportional? Let's say this one increases by 50%. So I'm going to put that in green. Then the bigger one would also increase by 50%. Okay? When one increases, the other increases at the same percentage. If one decreased, the other would decrease by the same percentage. So what to remember in terms of a formula for direct x equals ky. All right, so we've got to memorize that, where k is equal to the constant of proportionality. So k is the same no matter what. That's why we call it a constant. All right, so you've got that formula down here. So you need to remember that if a problem says something's directly proportional, you'll be using x is equal to ky. You might use a different letter than x and a different letter than y, but it's multiplication by the constant. All right, so as x gets larger, y gets larger. If y gets larger, x gets larger. Okay, let's do some examples and then hopefully it'll make sense. So our first example says a force of 15 pounds will stretch a slinky 8 inches. How far will the slinky stretch with a force of 30 pounds? It says that Hooke's law states that the distance a spring stretches is directly proportional to the force applied. So we're going to use, instead of x and y, I'm going to use d for distance and F for force. But you see how it's a very similar looking equation. I just want to use letters that make a little more sense. Distance equals a constant times force. Okay, so originally it says the distance that it will stretch is 8 inches. We don't know the constant, but we know that the force was 15 pounds. Okay, so solving for k is going to be divide both sides by 15, 8 over 15. All right, so now we have k. The question says, so this is usually what you do first. You're finding what the constant is. All right, so the question then says, how far will the slinky stretch with a force of 30 pounds? Okay, so we know that the distance is equal to k, which is 8 over 15. We just found that out. And the force is 30. So the distance would be 16 inches. Now you might could have done that in your head because you figure, okay, you double the force, you must double the stretch. Well, this is the math and how that works out. Sometimes you wouldn't be able to do it in your head like that. Okay, so let's try another one. So the next one says the area of a circle varies directly with the square of the radius. If the radius is a circle, if the radius of a circle is 5.3 centimeters, then its area is 88.2 centimeters squared. Find the constant of variation. All right, so the area, so the way you want to do it is read the sentence. It says area varies directly with the radius, square of the radius. So it would be, go from left to right with your equation. Area is equal to the constant times the square of the radius. All right? So we're just doing x equals ky. You're reading it left to right. Your equation is going left to right. So k then, solving for k, would be area over r squared. Well, it says our area is 88.2 centimeters squared. Our radius is 5.3 centimeters, but we have to square that. And then our centimeters squared, our units are going to cancel out. So if you, in your calculator, do 88.2 and divide that by 5.3 all squared, let's go ahead and do that. 88.2 divided by 5.3, but we've got to square that. That's 3.1399. Well, that pretty much rounds to 3.14. Where have you seen that before? K is just pi. All right. So that's direct proportion. You've really just got to remember it's in the form x equals ky. Read the sentence from left to right and make an equation that's in this form. You may end up having to square something. You may end up having to cube something, take the square root of something, whatever. Just read the problem, but your basic format is x equals ky. Usually you have to find the constant of proportionality and then plug that in. Okay, so let's move on to inverse proportion. So that's 2.9.2. Okay, so looking at our notes here, let me find that note sheet. So with inverse proportion, it says if two quantities are inversely proportional, it means that if one grows by a certain percentage, the other decreases by the same percentage. Okay, so our formula is x equals k over y for inverse proportion. X equals k over y. That's our basic format. So as if y gets larger, x gets smaller. And if x gets larger, y gets smaller. So they're not going the same direction. They're going opposite directions. Okay, you can read through this. If the arc example from the last section, we would say that the large arc is inversely proportional to the small arc. If the large arc grew by some percentage, the small arc was reduced by the same percentage. All right, well, let's draw that out. Our arc example didn't really leave you space to do that. But let's say we have a large arc and then a smaller arc. All right, if the large arc grows by, let's say, 50%, all right, then the small arc will decrease by 50%. So it's going to get smaller like that. So it's going to go that way by 50%. Okay, so that's inverse proportionality. So let's work a couple problems. All right, first example, illumination of a light source varies inversely with the square of the distance from the source. At 5 meters, a flashlight's illumination is 70 candela. What is the illumination at 12 meters? All right, first, you got to get an equation that's in this form. Okay, so I like to use, we're reading left to right, it says illumination, so let's use I, varies inversely, so K would be on top, with the square of the distance. Okay, so let's say distance is D, and we square that. So we've got an equation in inverse form. All right, at 5 meters, a flashlight's illumination is 70 candela. Okay, so we'd have 70 equals K over 5 squared. Okay, so if we multiply both sides by 5 squared, K is equal to 5 squared times 70, so 25 times 70. All right, so that is 1,750. Okay, so we have K. That never changes in this situation. We have K. So looking at, we want to know the illumination at 12 meters. So the illumination then would be 1,750, because that's K, over 12 squared. All right, so 1,750 divided by 144, that's 12.15, and the unit for illumination was given in the problem, candela. All right, pretty cool. Okay, let's see if I can squeeze this last example in and we'll be all done. So our last example says the power of an electric circuit varies inversely with resistance. If the power is 1,000 watts when the resistance is 12 ohms, what is the resistance when the power is 700 watts? Okay, let's read the sentence left to right. Power varies inversely with resistance. Okay, so power varies inversely, that means K's on top, with resistance. It doesn't say resistance squared, it doesn't say the square root of resistance, just resistance. So there is our equation. Now it says the power is 1,000 watts, so let's plug that in for power. We don't know K, and we know the resistance is 12 ohms. Okay? So K, we're going to solve for K. So K is going to be, multiply both sides by 12. 12 times 1,000. So that's 12,000. So the question says, what is the resistance when the power is 700 watts? Okay, so 700 is equal to, we know that K is 12,000 over R. Okay, so algebraically, if we're solving for the variable on bottom, we just switch those two. So R is equal to 12,000 over 700. Okay, so 12,000 over 700 is 17.14, and the unit for resistance, it says in the problem, is ohms. Okay, that's just named after a person. The symbol for ohms, if you ever take physics, you'll see is that. Right, kind of an upside down horseshoe. Okay, that will do it for this lecture. The homework is worksheet 2.9. So let me just eyeball that real quick and see if there's any hints I need to give you. I don't think so. Number 3 may gives people a little bit of trouble, but if you just read what it says, read left to right, you can figure it out. Yeah, I don't think there's any special instruction I need to give you on that one. Just try to get the units right, so be careful with units, and I will talk to you on the next video.